So I have 4 little reminder things that will be repeating some previous content, but also some new content. So one is evaluations. So Dan sent out a bunch of them last night. I was able to do the ones from yesterday during this last little break. It does not take a lot of time. And we really would like 100% response rate, please. And he's going to send out the ones for today soon. The next is COVID forms. If you received an email, such as the one I received saying you haven't received your COVID, blah, 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 please take care of that and send that. It's really important. The third thing is on the schedule, you'll see there's a special session tonight, the sort of science CA tradition, where we get together and talk about career development. And it's a really useful session. People like it a lot. So if you're able to come, please do. It should be really terrific. And then on the free day, so tomorrow in the afternoon, you have to not work on analyses of data. You could be thinking about Bayesian psychometrics as we all do all the time, but you have to be divorced from your laptop at that particular moment. And so there's a variety of things to do, and we'll get together tomorrow morning as a big group again, right back here at 9. Just as we've done every morning, we've gotten together at 9. And instead of lectures, we'll arrange who's doing what tomorrow. So that's tomorrow. So right after this talk, we'll break into work groups, and maybe depending on how we've all had terrific questions, and that may occur here, and we may punt on the work groups before lunch. Certainly after lunch, we'll break into work groups. We'll see how that goes. And then pretty much the rest of the week is in your work group, with the exception of these optional evening things like the career development one tonight, and then getting back together tomorrow at 9 to talk about what are we doing on our free half day. All right, so that's all of my announcements. It's a great pleasure to introduce Dr. David Fardo from the University of Kentucky, who's going to introduce the data and the data that we'll be working on in each of the work groups. So this is a very different flavor of talk. And another thing to say there is congratulations, you all survived. All of the didactics that are going to say like the word Bayes with math attached. So you did it. So, yay!
Yeah. Disclaimer, there will be no use of the word Bayes or didactic after the intro. So I want to say I'm super grateful for being able to participate in this conference, this workshop. It's unique, it's special on a whole different number of levels, as many of you readily know and others are learning. I'm a biostatistician, statistical geneticist by training, and I've been very welcomed into this community and very much appreciated. I have several goals for this talk. So over the next 2 hours, or 30 minutes, or however long it takes, I'd like to accomplish a couple things. One is just introduce ADNI as a general resource, drill down into what we're going to be using in work groups later today and later this week, and discuss a little bit about validity downstream. This is interactive. If you have questions during, please ask them. There are a lot of people with a lot of ADNI expertise in this room, so hopefully we'll be able to answer those questions. Down the road, in 5 months or 5 years, you may be interested in using ADNI, and I'm hopeful that this slideshow, this presentation, will help you jump up that learning curve downstream, just to make it a little bit easier to garner. So Alzheimer's Disease Neuroimaging Initiative, the study designs of ADNI, you saw a little bit in the last talk. It's pretty complex and comprehensive. You can see with this slide the different types of data that are available in different phases. You saw ADNI 1 and ADNI Go and ADNI 2 a bit in the last presentation. You can see here the different timing for those phases and the different collected data for those different phases. Oop. Can you see? Yeah. For those on Zoom, I'm trying to use my pointer. I'm wondering if you can see this, but I'm trying to do this for you guys. Left to right are timing from screening and baseline to periodic visits. So on screening, there's demographics, some lab work, medication, cognitive assessment, etc. You can see in the legend the different diagnostic categories from each stage, and I'll get into that in a little bit as well. So fairly comprehensive. Some of the discussion in the last talk was great about learning effects and using either MCI conversions or potentially using cognitively normal folks who convert. It's very important that you understand the design and the limitations of ADNI. It's not a one-size-fits-all data set. The study that you have in mind, the hypothesis that you want it to test necessarily ADNI was not prospectively designed to test that. So it's important to understand that as you're doing your analyses. And I thought that was a great explanation at the end of Chun's talk about learning effects kind of getting were not important for the question at hand. This slide, evolving study design, initially said statistical limitations. I thought that was harsh. And I realized that's not harsh, it's reality. Again, you need to understand the design in order to be able to do an analysis that makes sense and you're able to do any inference on it. ADNI 1 started with 200 cognitively normal, 400 with mild cognitive impairment, and 200 mild AD research volunteers. So those research volunteers were ascertained based on these diagnostic categories, these disease categories. It got added onto by ADNI Go, and they introduced the early MCI group. 200 subjects were recruited into that category, and 500 were rolled over from the cognitively normal and the MCI ADNI 1 participants. 200 additional mild AD were recruited. It gets complex quickly. ADNI 2 adds additional rollover, additional recruitment of cognitively normal, of early MCI, and they add late MCI. This is a good time to say this presentation has links to a lot of the resources that ADNI provides. So if you need to delve deeper into a question of interest that's pertinent for our work groups later on this week or later in life, they're readily available. Alden has a question that I'll repeat.
Yeah, this is just a simple language thing. What does rollover mean? Does it mean people from ADNI 1 are come back for ADNI 2?
Yes. I won't repeat it because you used a microphone. Thank you. So it is complex, and you can see in the rightmost column that the cognitively normal and MCI rollover from into ADNI 2 were from ADNI 1, and there were some early MCI rollovers from ADNI Go. That's mentioned parenthetically. Again, this gets complicated quickly, and understanding that is important, paramount, I would say, for whatever question that you're trying to answer. I believe Roy had a quote from George Box earlier. I think this is most often attributed to him, that all models are wrong, some are useful. That's very true. Whatever you're doing, whatever I'm doing is necessarily wrong at some level. The more you know, the more you realize what limitations it has. But if you get a good enough, that's what really we're shooting for. ADNI 3 adds in a similar fashion. They're now recruiting for ADNI 4, from what I understand. Specifically for data acquisition, you guys know this, that I'll say theoretically, everyone has already gone through the ADNI data access and permission process. So you've seen this already. But I'm putting up the links so that downstream, if you need them again, you can use them readily. So here, the access page, the login screenshot, a listing of all your different projects once you go into My Account. The data use agreement, again, should be familiar. information is readily accessible. So you can play around on Lonnie. That also has other studies besides ADNI, and get a whole host of information. Most of the information you don't want or care about at all. So that's sometimes part of the challenge, is narrowing down what you need. And what the organizers have nicely done for this workshop is provided what you need. If you want some ancillary data, though, you'll be able to use these links to garner that. You can get descriptions of the data from a high level, with age categories, by diagnostic category, by gender, etc. There's a lot of pubs. There's almost 4,000 publications that have been generated from using ADNI data. You can search on that left arrow. You can, a lot of the SciMCA organizers have published considerably in ADNI. We'll see a couple of those publications. But yeah, it's a phenomenal resource. Again, all those limitations as a caveat, they make it very easy to get these data, and hats off for generating that resource and keeping it going all these years, almost 20 years now. So this week, specifically, what we're going to be doing for the rest of the week, we have harmonized cognitive scores among other data. And I've just highlighted 3 different data sets. This is the screen that you see when you're in the download area of Lonnie, specifically in the study data area. On the left, you can see categories in green. Again, it's sometimes a little difficult because there's so much to narrow down what you need. Don't be afraid. It gets a little bit easier. These 3 that I've highlighted are from the ADSP Phenotype Harmonization Consortium, which is very well represented here, and what is generated the harmonized and co-calibrated executive functioning, memory, and language scores that we'll be using in work groups 1 through 3, likely 4 as well. The first paper, and you'll notice in gray, that is a Friday Harbor 2011 workshop special issue. So this is something that was explicitly generated from this workshop, which I think is super cool. This was the memory ADNI MEM, the original ADNI MEM harmonized phenotype. Work group 3 is going to be working on that. Work group 2 has the executive functioning metric, again from Friday Harbor 2011. And work group 1 is using the developed and validated language composite scores that Seun authored. You see Joey and Laura and Elizabeth and Rich and Doug and so many names you should recognize from this room and elsewhere that are experts in the data that we're going to be using. Again, questions can be answered if you have them. You'll go a little bit deeper in work groups. I'm not going to go through each of the 3 categories. I'll show you the data structure. You guys have access to the box where those are. I'm just going to give you a little bit of an intro into how to get answers to the most likely questions that you have. Here are the data sets. There's a bonus data set that was not here at the time that I took this screenshot, but you can see that's on imaging data. That's accessible to you. It will require a little bit more of data munging if you're going to use that. I'll leave it at that, other than if you end up using it, you should make the appropriate acknowledgments that are listed in that data set. Let's take a deeper dive into the code book. So in the code book, you'll see variable name and description. These should be, I say, self-evident. It's self-evident when things are well documented, and this is well documented. So you can scroll down and see what each of these variable names represent. And we'll take a deeper dive into looking at the data for executive functioning in a bit. But this should answer 90+% of any questions that you have about the data. Each of the 3 domains has 3 different files, CSV, kind of separated file, a DTA data file, and then a data dictionary. And the data dictionary, as you can see here, I'm sure everyone in the back can read the last columns, I would guess. Not really. Even blowing it up, you can't see. But again, typically the more documentation, the better. And this is the case here. You can see in that data dictionary for each of the 3 domains is a pretty specifically documented list for each of the variable names that we have access to, including recodings that were done for Stata or M+ that has limitations on the number of variables that can be entered. Yeah, the data dictionary has a key tab as well that's informative. I'll get into, actually, I'll stop there. Questions about data structure before we jump in. I'll take a deeper dive into executive functioning here shortly, just to look at the data. Yeah, go ahead, Tim.
I just wanted to mention that there's also a searchable data dictionary for ADNI overall online, so you can also launch that and search. Some of these are derived variables that the IDE put together, so it can be on there. But the data that comes right out of that, you can search the dictionary.
Thank you, Dr. Homan, who runs the ADSP Harmonization Consortium and is very intimately involved in this. So use the search functionality in ADNI if your question's not immediately answered in the documentation that Joey and the rest of the data crew have put together. Again, ADNI is set up in general to be extraordinarily user-friendly. It's one of the hat tips to that initiative. Other questions, comments? Thanks, Tim. You're going to be going into this in a whole lot more detail in work groups very shortly, but this will hopefully accelerate your jaunt on that learning curve. I'll give a hat tip. We've had a lot of chat GPT talk this week already. I just Googled exploratory data analysis using R as I was preparing this, because there's always something new. So if you already have your the way that you like to explore data, good for you. I like to kind of play around and see what's newly available, and I've used some of those. I've used screenshots and opted going the screenshot rather than the live presentation route, largely because we are on Zoom as well. But I have a link here to Little Miss Data, who helped me at least learn some new packages in R. A lot of you are new to R, or that's not your primary statistical language, which is great. So hopefully you're getting some extra tools for your tool belt this week and in this talk as well. So bringing in one of the data sets for, in this case, executive functioning, using a read-R library, and then exploring that. So here, I'm just using the view function, capital V, to see the data. This is the same view that you will get if you open that CSV in Excel, but now it's actively in R, which provides you a couple different extra things. You can notice that this data is in long format, which means that for each row is a visit. So each subject is going to have multiple different rows corresponding to different visits that they've had through their ADNI participation. Looking at the top one is ID 2, and that person has had 11 different visits. You can see that in the ID column, and the viz num variable gets to M144. that due to good coding and good data documentation, I'm going to take a wild guess that means it's month 144. Right? So a lot of this is intuitive, and thank you to those that make it that way. dplyr, tidyverse is I say newer. It's been around 8 years or so, and people love it. The glimpse function in dplyr provides a glimpse at the data structure that you have. So you can see here on the bottom left what glimpse gets you. It lets us know immediately that we have 11,600 rows, which means there's 11,600 unique visits across these research volunteers, 61 columns. That should comport with the Excel file, the CSV file. And you can see here some descriptions that this is coded as a double and a character, and so on. And you can see a glimpse at that data without actively opening it. Similarly, the base summary function, summary of EXF, gives us an idea, tells us about ID, the variable study, visnum, phase, et cetera. We can see for the Ray VLT, some summary statistics here. We had, it's kind of nonsensical that the mean of something that's either 1 or 2 is 1.205. It tells us that, I guess, 20.5% of those visits were ones. But for age, we can see a little bit more informative information, including that there's somebody with age 0, which may be data's never perfect, I'll say that. So there may be someone that's newborns, the newborn recruitment. That's ADNI 4, right? The newborn recruitment. Kidding. So you see just again a summary of the data set that you've brought in. This is I think James mentioned yesterday. Anytime that he gets a new data set, what do? You look at it. So this is a quick way of looking at it. Another library that was new to me is Skimmer, and the skim function from that package gives a host of other information. And here we can see just other descriptive information about the data set. That's a good thing to pay attention to when you're first looking at any data that's new to you. It may uncover coding errors. It may uncover structure that you didn't know beforehand. It may, as he mentioned yesterday, gives you an idea of what those actual variables are, if they're constrained, if there's I think there was an MMSE max of 30, for example, that was discernible by an exploratory data analysis. This skim function shows a very briefly, palatably, histogram of these variables and quantiles. Another library, VisDat, gives visual representations of missingness or of the data type. Again, this is not intended for us to take a deep dive into this right now, but just to give you some tools in your tool belt to be able to explore on your own when you get into work groups or for the future as well. Another fun one that was completely new to me was Data Explorer library, which, calling the create report function from that library, creates a report. Again, good coding is extraordinarily useful. This report by default provides a handful of things: basic statistics, structure, another missing data, and distributional snapshot, correlation analysis, PCA, things that may give you some insights in the data that is new to you, or you've dived deeply and just want to have some flavor of visual representation. This one's just a couple screenshots from that report. You can kind of make some quick inferences. Looking at this missing data profile, you see that there are certain items or certain variables that have a similar missing data profile, which makes some sense if we go into those variables and see that they're in the same battery, for example. You can see histograms down at the bottom as well. And I'll say this, if you have your own EDA flavor, your own pipeline that you like, great. Maybe seeing these will further solidify the fact that you love your own EDA pipeline. If that's not the case for you, you might pick one or two things that are helpful downstream, again, either later this week or 5 years from now. Of course, 5 years from now, those tools will likely be very different. Inspect DF. I got so tickled. So I was kind of like Alden and Brandon last night going up to James with a laptop of like, let's, how do we change this this function? So I got a little carried away with my EDA, but Inspect DF was super cool. Just a different way to look at the data. Here you see data types and missing this in a different presentation. But again, you can glean important information about your data set in this way. With Inspect DF, you can also compare different data sets. So I decided at this point to cut up the executive functioning data set by disease category. And so the subgroups were the normal cognition, MCI, and AD. And I did that. I guess you might need the tidyverse dplyr. This might be in dplyr, but regardless, I separated those and then compared the missingness profiles of the normal folks and then the AD subjects. And again, just exploring, but I can maybe make some preliminary inferences about what's what here. The normals are in red and the ADs are in blue. Interesting. AD DX Viz, there's a lot more missingness for normals than ADs. In this whole group, there's a lot more normals. There's a lot more missingness in the ADs than in the normals. That may or may not be important, but it's easy to visualize. Because we're interested in a lot of the time, like our last talk of longitudinal inference analyses, I made some very quick spaghetti plots with ggplot. And all these are doing separated by AD, MCI, and normal cognition. And just for a subset of folks, because if I were to do all 11,000 visits, this would crash or at least become unreadable. But what these plots are over by age, people's executive functioning, harmonized executive functioning over age by person and categorized by diagnostic category, AD, MCI, and normal. And we can see fairly readily the increase by from AD to MCI to normal. I guess if we flip-flop that, we'd see a decrease. Again, ways to explore your data. And these are the data that are available to us this week. You'll have a whole lot more to come. The info share that you guys have already been on in Box, I'll go over that quickly. 3 main folders: data, our tutorial, which Sam did yesterday, which was great, and then talks. In the data folder, there's a subfolder, papers and resources. I guess before I get into that, these are all the data sets that I showed before. There's a couple bonus ones that you can look into that I haven't talked about, but if they're of use, then absolutely take advantage of that. In the paper and resources subfolder, there is a README file that I highly recommend you do. README. And it's very well laid out. Again, like data documentation is fantastic. And the resource documentation is fantastic. And here you see within the documents that are shared, a high view of what they are. So 002 is the Mukherjee et al. Paper, Cognitive Domain Harmonization and Co-calibration in neuropsychology, and talks about the workflow for co-calibrating cognitive tests, et cetera, across different studies here, including ADNI, but also with Ross Map and ACT as well. I'll go into this and very briefly. The Crane et al. 2012 paper that was the original ADNI mem that came from this conference. In that abstract, I actually will read this verbatim. Our primary goal was to develop and evaluate the validity of psychometrically sophisticated memory composite score from ADNI, close to verbatim. We compared our memory score to a variety of other scores, and here's how we tried to address validity. First, tried to detect change over time by diagnostic group. This is important parenthetically. Why by diagnostic group? Because this is ADNI data, and you need to respect the fact that subjects were ascertained based on diagnostic group. So detect change over time in that memory score, and did that comport with groups? Predict conversion from MCI to AD, which we saw a bit about last hour. And correlate MRI metrics that are known to be related to memory with the memory score, and then contrast rates of decline between those with those without AD, those that are cognitively normal in MCI, with and without the CSF-based AD signature. So this is an example of what was the approach taken to show validity of a metric, and there are a lot of folks in this room that are better suited to go into those weeds, but this is a glimpse there. Questions on this, or Paul, do you want to say anything else on validity? Okay. Extra slides. We have this is actually one of the resources in Box, the 004 factor models for ADNI data. And these are going to reflect or show what the models that those initial ADNI scores, how they were developed. In the language group, the working group 1, here are all of the, or a snapshot of the different items, some coming from ADAS-COG, or BNT, or MMSE and MoCA. And here, this is a single factor model that uses all of the items that are pointed to. We've seen a lot of different model structure diagrams. So this is a model structure diagram showing what the original, this is the original ADNI language score. Similarly, for executive functioning, here are the items that were used for executive functioning, and including their secondary structure. This again, these slides are in a separate PowerPoint in our Box folder, and this shows a bifactor model that shows, for example, digit span backward total corrected and digit span forward total correct were comprised a secondary structure F2, and then 4 other items were had a secondary structure. Trails A, Trails B, digit symbol total correct, and number cancellation task from ADAS-COG. Similarly, for the memory group, working group 3, here's the battery, and we can see to expect a bifactor model is coming with 3 different secondary structures, and it's laid out like that. So I believe, yes, memory and SEs also come from this model. SEs are available in the data that are provided. Those are from an updated model that has been harmonized and co-calibrated with additional data over ADNI's extensions. I'll also say this: ADNI's evolved over time, as have neuropsych batteries. That's another thing that's important to keep in mind. The bonus data set is some imaging data. Imaging technologies have evolved over time. The beginning of ADNI to now is about 20 years. Those things have changed, so it's important to recognize that some of the same measures are not really necessarily measuring exactly the same thing. So I'll open it to questions.